Futuristic Spaceships, the high-stakes race to conquer the red planet. A new era of interplanetary travel is dawning, with a fleet of audacious, next-generation spaceships poised to turn science fiction into reality. The long-held dream of sending humans to Mars is no longer a distant fantasy, but a tangible goal, sparking a 21st-century space race fueled by the ambitions of private companies and national space agencies alike. At the forefront of this cosmic contest are revolutionary spacecraft designed for long-duration missions, featuring cutting-edge propulsion systems, advanced life support, and ambitious plans for sustainable colonization. The undisputed front-runner in the private sector is SpaceX's Starship, a colossal, fully reusable launch system that stands as a testament to Elon Musk's fervent desire to establish a self-sustaining city on Mars. Towering at an impressive 120 meters, the stainless steel behemoth is designed to carry over 100 metric tons of cargo and up to 100 passengers to the red planet. Starship's groundbreaking design incorporates several key innovations. Its 6 powerful Raptor engines, fueled by subcooled liquid methane and liquid oxygen, are engineered for high performance and reusability. A crucial element of SpaceX's Mars plan is on-orbit refueling, where a dedicated tanker Starship will replenish the Mars-bound vessel in Earth's orbit, enabling it to complete the months-long journey. The company is aggressively testing Starship prototypes with an ambitious, albeit fluid, timeline that aims for the first uncrewed cargo missions to Mars in the late 2020s, followed by crewed missions shortly after. Not to be outdone, the established giant of space exploration, NASA, is steadily progressing with its own plans for human missions to Mars, targeting the late 2030s or early 2040s. Central to NASA's strategy is the Space Launch System, SLS, the most powerful rocket ever built, designed to launch the Orion spacecraft, a capsule capable of carrying astronauts on deep space missions. While Orion will serve as the primary crew vehicle for lunar missions under the Artemis program, NASA is actively developing concepts for a deep space transport vehicle for the long journey to Mars. These concepts often involve assembling a larger habitat module in space, launched in sections by the SLS. NASA's approach is more methodical, with a strong emphasis on developing and testing critical technologies for long-duration spaceflight. These include advanced life support systems that can recycle air and water with near-perfect efficiency, robust radiation shielding to protect astronauts from harmful cosmic rays, and innovative power systems for the Martian surface. In this high-stakes race, other formidable players are also making significant strides. Blue Origin, founded by Jeff Bezos, is developing its heavy-lift reusable rocket, New Glenn. While initially focused on satellite launches and lunar missions, New Glenn's capabilities position it as a potential vehicle for future Mars endeavors. The company has already secured a contract with NASA to launch the twin Escapade or Escape and Plasma Acceleration and Dynamics Explorers probes to Mars, demonstrating its growing role in interplanetary exploration. Aerospace titan Boeing is a key partner in NASA's Mars ambitions, serving as the prime contractor for the SLS core stage. The company is also contributing to the development of technologies for deep space habitats and transportation systems, leveraging its extensive experience in human spaceflight. The technological hurdles on the path to Mars. The journey to Mars is fraught with immense technological challenges that all contenders must overcome. Propulsion, While chemical rockets like those powering Starship and SLS are capable of reaching Mars, the long transit times expose astronauts to significant risks. Therefore, research into advanced propulsion systems, such as nuclear thermal propulsion, or NTP, and nuclear electric propulsion, or NEP, is a high priority. These systems promise to significantly reduce travel time, thereby minimizing radiation exposure and the physiological effects of prolonged weightlessness. Life support and sustainability. A round trip to Mars could take over 2 years. Ensuring the well-being of the crew requires a closed-loop life support system that can reliably recycle air, water, and waste. Furthermore, the concept of in situ resource utilization, or ISRU, is critical for long-term sustainability. This involves extracting and processing local Martian resources, such as water ice and atmospheric carbon dioxide, to produce breathable air, water, and even rocket propellant for the return journey. Human health. The harsh environment of space poses significant threats to human health. Astronauts will face prolonged exposure to radiation, the debilitating effects of microgravity on bones and muscles, and the psychological challenges of isolation and confinement. Developing effective countermeasures and robust medical facilities for the spacecraft and Martian habitats is paramount. Landing and ascent. Mars' thin atmosphere makes landing heavy spacecraft a complex and perilous maneuver, famously dubbed the 7 minutes of terror. Developing reliable and scalable descent and landing systems is a major engineering challenge. Equally challenging is designing a Mars Ascent Vehicle, or MAV, that can launch crew from the Martian surface back into orbit for the return journey. The race to Mars is more than just a competition. It is a testament to human ingenuity and our innate drive to explore the unknown. The futuristic spaceships being developed today are not merely vehicles. They are the crucibles in which the technologies and strategies for humanity's multiplanetary future will be forged. The coming decade promises to be a pivotal period as these ambitious endeavors transition from the drawing board to the launch pad, bringing us one giant leap closer to setting foot on the red planet.